Welcome, everyone. Today's webinar is about Acselerant. We're transforming testing with Acselerant Software. Thanks, everyone, for joining us. I'm Roy Kranz. I'm the host today. I am the Software Development Manager at ACS. And joining me today, let's move down. I have Daniel Palmer and Ed Seckel, who are both software development engineers that also put a lot of time into the Acselerant software. We're thrilled to have all of you with us today. Feel free to post questions throughout the webinar, and we'll try to either answer those during the various slides and demos, or after at the end. So I'm gonna short little intro video here. I'll just get that started. Okay. Our agenda today, we'll start off talking about some of the industry challenges and pain points across kind of tested measurement systems. We'll introduce Acselerant and go through some of the key features and benefits that it has. We'll try to touch on most of the major components of it. I mean, there's still a lot of detail and so on that maybe some follow-up meetings or webinars may be able to explain all of the key features and benefits. We'll try to talk about a few real-world applications that we've used Acselerant on and how Acselerant helped us basically achieve success with those systems. We'll just touch a little bit on some future innovations and trends of where we see Acselerant going and of its possible improvements in the future. And we'll end with a little bit of live question and answer if anyone has questions or wants a little more detail on any particular item that they see. So I think the total time we have is roughly an hour. We'll try to wrap up most of the slides and everything before that, so we do have some time for some questions and answers at the end. So, at a high level, it's kind of what is Acselerant? It's a real-time test application that runs on NI real-time controllers and talks with a kind of a standard Windows PC. So you see in the picture there, we have a Dell PC on the top is just normal Windows PC that's going to provide an HMI and talking to a real-time controller on the bottom. The hardware that Acselerant typically uses, we look at the NI real-time controllers, so a PXI-based controller or a C-REO-based controller. PXI would be the high end, lots of horsepower, large complex systems, where the C-REO would be for smaller systems, not as demanding as PXI-based systems. It'll connect to a variety of DAC devices, either NI-based devices or third-party-based devices. EtherCAT communication is common. We use that in a majority of our systems. Again, talking to NI-based EtherCAT or third-party-based EtherCAT. And then support for various communication protocols. Modbus, AirRink, Serial, CAN, that sort of thing. On the software side, Acselerant is LabVIEW based. So it's core, it's all written in LabVIEW. On the real-time side, on the HMI side, it's all LabVIEW. and it's designed to be very modular and flexible. And we'll get into a lot of that flexibility as we go through these slides. On the software architecture, this is a real quick high-level overview. This is where we have a GUI application. Its main job is really just presenting the information, different widgets and graphs and stuff like that. Purely Windows, and it communicates down to the real-time controller. And on the real-time controller, we have what we call various modules, and those modules are, drivers, communication buses, machine logic, pretty much whatever selection we want to put together to build a particular system, all in a standard modular framework. So then really, how does this architecture of Accelerant help to address some of these various pain points and challenges? Some of the big ones, a lot of systems are, they're proprietary. A lot of them are locked down. You don't have full access to the software. On Accelerant, you actually get the entire source code. We have a very flexible site license where you're free to put it on different machines at that same facility with no additional licensing fee. We give you all the source code, and you no longer really need to talk to us. You can just keep putting it on whatever machines you want. We think that's it's a very good strategy going forward. It doesn't lock you in. It gives you complete flexibility, but I think it also helps establish a framework, a foundation, so you don't necessarily have to have a lot of disparate test systems. You can have a number of test systems that are based upon a core framework. The integration difficulties with various hardware, talking to this instrument versus that instrument. The flexibility of Accelerant allows you to substitute these modules, whatever kind of modules you want to write and combine, you can. If we haven't written something to talk to a particular instrument, maybe it has some weird protocol, you can simply create a new module for that and integrate it into your systems. Scalability problems. Again, if you're you need to expand the number of channels, the number of calculations, the number of test scripts, anything like that. How can you do that? We haven't built into it any inherent limitations. Your primary limitation is just computational horsepower as you build more systems. Adding additional I/O, since the majority of everything we do is configuration based, you simply add the I/O, update the configuration to include the new I/O, and now you're ready to go. Complex customization. Typically, that is a difficulty if you don't have a standard product, right? If you're not, if it's not a standard dyno, you want to do something a little odd. Maybe it's a R&D type of situation. We've designed Accelerant to be customized. We expect it to be customized. That's why typically it is not, oh, I've installed it and now I'm done. Usually it's, I've installed it, it's now I have 80 to 90% of what I need. And on top of that, I have to add my customization. I have to figure out, do I need a new driver? Can I talk to that particular device, or am I going to have to work on that? You can customize all of your calculations, your scripts, the machine logic, all of that can be customized through all the Accelerant features. And of course, then some data handling limitations. Like, what do you do with your data after the fact? Again, with our modular design, we have the freedom to really do whatever we want with it. If you just want to put it in a file on a hard drive somewhere, that's fine. If you want to add different communication to databases and so on, there's modules for that as well. So I'm going to just kind of do some quick showing of some of the little features that are built into Accelerant. And then eventually we'll get into more detail of each of them. Let's see, I have to adjust my share. So one of our configuration utilities, and this is somewhat detailed, but we can use our configuration utility to build a project. So when you're first starting at a really high level, you start looking at, well, am I using EtherCAT? Am I using normal DAC? Am I using Modbus? All of these, how many machines am I controlling with the system? And we have just a fairly simple high-level definition file that you just start building all of these systems. Or basically including them in your project. You're like, oh, I'm going to need Modbus. I'm going to need CAN. I'm going to need this and so forth. And once you build that, you can set order, order of execution, routing, all sorts of that information. And it's just simply defined within this utility. Once that executes, we have another utility, a utility basically on the controller itself that provides a little bit of feedback, a little bit of information of, all right, this is what I have. You can go and you can look at, this is what's deployed down on the controller, right? This is what's actually down there. You can look at, this is what's actually installed. Like, here's the modules I have installed. I have CAN, I have Visa, I have EtherCAT, and so on. And this can include any number of modules that are installed, custom ones that basically ship with the product. And it lets you know, here's the build, here's what's down there. And so whenever you assemble a system, you can just pick and choose what you want, what you need. And then on the HMI side, what does an operator see? If an operator comes in and, does he want to see a lot of dials, meters, gauges, charts? What is it? Whatever he wants to see. That is something that our dynamic screen will allow them to see. And we'll get into a little more detail on this. There's tons of options in here, but we'll definitely kind of do a deep dive into here. So let me switch back to the presentation. Okay, so we're gonna have Ed talk, kind of go into a little more detail of some of the features of the HMI. So go ahead, Ed.
So now that we've discussed some of the challenges, let's explore Accelerant a little bit more itself. So what is Accelerant? It's our LabVIEW-based real-time control platform for test systems. And we've built this on 4 core principles. So determinism, we want to make sure that we predictably execute at the expected time the inputs and outputs and calculations of the system on a real-time platform. Modularity, we have the ability to add multiple modules and configure the system based on whatever size project we're working on. So if we need to, as Roy said, if we need to have EtherCAT IO or DAC MX IO, or if we need to have Modbus or Ethernet IP, we can add those modules into the system and then configure that IO and route it to a main, what we call machine module typically, where we would define the overall process of what the system is going to do. So that's where we would determine how it's meant to operate and what functions are configured for the system. So it's also designed to streamline the test automation and data acquisition, and it's definitely scalable across multiple industries, from automotive to aerospace to other industries as well. So let's go ahead and share my screen here. We're going to go ahead and jump into the dynamic user interface. And let's take a look at what we can do with the user interface itself. So here we have some example screens that are configured. This main screen or main interface includes some pages which can be linked to these buttons that appear on the left. You can have multiple buttons that are configurable. You can configure the images, the names with the buttons, and we can create different screens to tie to the buttons. So all of this, again, is dynamically configurable. Here's some examples of some screens that we've created. So you have the ability to add widgets to the screens. When you add the widgets to the screens, it allows you to link back to any of the variables in the system that have been defined. So here we have some widgets that we've defined. We can come in and we can select a channel in the system. I want to link this to just any variable in the system. I can link it to the variable in the system and it'll start updating. We have quite a few different widgets that we can use. There are graphs, there are list indicators, there are numerics. The numerics we can configure so that the background color changes. We can configure it so based on the value, it displays certain enumerated text. We can also flash the controls when it's outside of a certain value. Another really cool feature that we have here is we have the ability to add synoptics to the system. So we can actually configure an image as the background of one of the screens, and then we can overlay some widgets. So you can see here I have a few on the screen. I have a speed and I have a pressure. And then I have an indicator for the filter dirty that we've overlaid. And we could overlay additional widgets in different areas of this. But we do have the ability to go ahead and apply any image as the background and overlay all of our widgets, giving us a nice representation of what we really want to see on the screen. So if I wanted to create a new screen, I can very simply just click and create a new screen. And the system creates a new screen for me. And there's no limitation on the amount of screens that you can create. And then to simply add a widget, I can select any of the widgets that we have in the system and add it to the screen. And from there, we can link it up to one of the values. And give it a label. And now it's reading from that value itself. We're updating that variable. The screens also have properties that can be assigned. You can assign names to the screens. And you can also select some default options. You can make the screen auto launch, change the background color, restrict the screen to administrative access only. Here's where you can set that image I had mentioned for the synoptics. And you can set up different modes for the way that that's applied. Once we've created the screens, we have the ability to go in, and as I had mentioned, we can link those screens to the buttons and we can name the screens. So here you can see in this drop-down list all the screens that I've created, and you can see where I've assigned a screen. If a screen's already been assigned, it shows up disabled. You can only assign one screen to a button. And then any buttons that we don't want to use, we can configure to be disabled. Then each of the buttons we can label with whatever text we want, and we can choose an icon from a vast icon library to go with the button. Additionally, we have a status screen that's always visible. This is configurable from a vertical location to a horizontal location. And you can also set the width, whether it's wider or taller, based on what your preferences are. This status screen is actually just another screen that's configured and linked, and you select it, but it appears all the time, no matter what page you're selected on. So as I change pages, you can see that my status screen stays constant. Now that we've looked at the user interface a little bit, let's talk about some of the definition files. So in share here. So in this example project that we're looking at, we have two different modules that are configured. As Roy mentioned, you can have a lot of different modules. So we've created an EtherCAT module for some I/O, and we've created a machine module to handle some of the logic. So once we've defined the module that we want to use, and we've defined the definition file that we want to create, then we can look at that definition file. Share that. And so here's an example definition file for the machine module. So the machine module would contain the overall logic that we're looking at in the system. And we can set up some general parameters, the rate at which it executes, the number of threads. We can turn on the alarming and limiting. And then in the next tab, we can define some of the variables in the system. So we essentially can define every variable that the machine module is going to contain. And so within this, we can split them up based on sections. We have some fault code here and some I/O. Additionally, we can set alarm parameters for these modules. And with the alarm parameters, if it goes outside of the alarm, you can configure it to execute a certain state, which is another defined script that would cause the system to perform a certain action. And all of this will be executed down on the real-time side. So you're achieving a deterministic control and execution while this is being processed. So here's an example of those states. And typically I might be operating in the main state. And if I trip to a fault state, then I would perform a certain process to shut the system down or put it in a safe state. We talked a little bit about the ability to define some controls. So you can configure um, different controls that you want to have in the system. So you might have a drive object that's a control and a device under test that's a control, both with torque and speed modes. And we can define variables that are the set points, the feedbacks, and the output channels for these PID controls and feed forward controls. And then additionally, we have support for advanced calculation scripts. So the advanced calculations happen deterministically on the real-time side, and they execute every iteration. So we can create a calculation, as many calculations as we want, and we can execute those calculations. They'll execute from left to right and top to bottom. So here we might be doing something where we're looking at the drive to determine whether it's enabled or disabled. We might be switching automatically if we exceed a certain limit, switching back to a different control mode. So we have quite a few capabilities there. Additionally, we have the ability to define logging in the system. That can be configured in the definition files, or it can be configured dynamically. So when we set up our log files, we can configure any of the variables to be part of a specific log file that's predefined. And we can predefine our log files here. So in this tab. So here's an example where we've predefined a main log file that starts immediately at a rate of 1,000 hertz. If we wanted to define that dynamically through the HMI, we could also go into the data log setup, and we could come into the configuration, and we could add or remove any channels in the system that we wanted to. So we could also create new configurations if we wanted to add a new one. And give it a name, and then select channels from the system that we wanted to add in to the log file. And we can just configure the rate of the log file. And set up any start and stop triggers that we might have for that log file.
All right. Let me share. I want to show a few other little features. Let's share. Let's share this full screen and switch to this. Okay. So Ed was talking at the end. He was talking a lot about the configuration files that we use to do a lot of these settings. You don't have to do all the settings through the configuration files. There's APIs that also allow you to do those communications without necessarily doing the file. Some of the other tools that we have, there's a lot of built-in tools, the PID tuning, calibration, we have forcing tools, event tracking tools. We do have a test sequencer on the HMI side and on the real-time side. So on the Windows side, we can go in and create high-level sequences. So I got a simple one created here. Those sequences include a variety of steps, however you want. The steps that are defined, you see them here on the left-hand side of the window. There's fairly standard sequence step types. So there's looping, there's setting values, there's conditionals, specific log creating, report formatting. Each of these steps, you don't have to remember the syntax here. They're all dialogue driven. So dialogue comes up, you enter the values, and it generates the script for you. And like a lot of parts of Accelerant, all of these steps are dynamic. So you can actually create new step types and the system loads them dynamically. And we can do this with our widgets, our services, our step types, each module on the real-time side. All of those are dynamic components that can be pulled together when the system runs. So these sequences, inside these sequences, we can do sort of high-level Windows-based sequencing, but then we can also do real-time executions as well and tell the real-time controller to execute a sequence. And vice versa. The real-time side can, in fact, control the Windows side and tell it, hey, run this high-level sequence. So if I execute this one, it's just doing a perpetual loop of just modifying a set point a little bit over time and then going back to zero. Somewhat non-deterministic because I'm not telling the real-time side to do this. I'm just doing it on the Windows side. But in many cases, that's sufficient. You don't need the tight real-time control. You let the real-time controller do it. And on Windows, you're just doing sort of high-level, hey, just turn this on, turn that off kind of control. Let me switch back to the presentation. Actually, I should be able to just close this. Okay. All right. I should be back on the slides.
You are.
Awesome. Oh. Okay. Now we're going to talk about some real-time, some real-world applications. Daniel is going to start talking about this particular system.
Yeah, so this test system here was we developed for a customer who was developing control modules for an aviation application that actually went into a full Iron Bird type setup. And so there were all kinds of control modules that had to talk to some master controllers. So what our customer was doing was they actually started out running a plant model versus a model of their controllers, but also needed to access external communication buses to talk to the other parts of the Iron Bird. So Accelerant was able to route those signals, from the models out to either physical I/O or communication buses. And then as they developed and further progressed the program and actually got into the actual physical control modules, those were installed. And then we were, just through changing some simple routing, able to take those control modules and hook them up to the same physical I/O, the same communication buses. And so it was a seamless switch between running a model-based system and a actual physical HCM, which allowed them to do all their testing and integration with the rest of the aircraft. Another application we've done that has really taken advantage of a lot of the flexibility that Accelerant provides is we've partnered with a customer of ours to help them use their power supplies and electronic loads for battery testers. And so we have developed a box that runs our Accelerant software on a real-time controller and a Windows PC in the box to allow them to hook up their power supplies to batteries and do controlled charging and discharging. And with the flexibility of Accelerant, we've actually provided, instead of those Excel files that Ed was showing earlier, we've provided a fully customized configuration experience that lets them configure the CAN as an end user who's using this product rather than a developer who wants to get down into those weeds. We've provided a higher end solution to be able to configure the systems so that any user of the cycler can easily do that without having to know the Accelerant specific scripting languages, and the tools that go along with that. We automate all that. Additionally, that has custom widgets for displays that their users would be more familiar with, that are similar to their power supplies. We have custom test steps in that sequencer that allow them to do charge and discharge and rest, and actually directly interface with their system. And another advantage of Accelerant is that as that product is going out to more and more customers and they're requesting additional features, we're going to be able to quickly add other modules if they need to be able to communicate to devices using Modbus or other protocols. We're going to be able to quickly integrate those additional features without having to rewrite huge chunks of the software, and just add those modules in as we go. So I'll turn it back to Roy.
Yep. One of the other applications, a little bigger application, was a powertrain dynamometer, where we configured Accelerant to do 2 axes of control with the electric powertrain unit set in between these 2 motors shown here. One of the difficulties with this system was that the device under test didn't exist and wasn't going to exist until all of this was built and shipped to the customer. So we need a lot of flexibility to answer a lot of questions that wouldn't be answered until we're actually sitting there connecting up a unit. We had to do the communication to their unit to put it into different control modes. The control mode torque on the dyne it's pretty standard, fairly straightforward. But again, we had to communicate with multiple chillers based upon the particular flavor of the unit that was coming in, multiple battery simulation systems, actual batteries themselves, and all of that had to be worked out after the fact, after this equipment already existed and they were developing their unit to actually go into here. And that's actually one of the big challenges of test equipment, is if you don't really know what your system is, creating this kind of a generic test system can be very challenging. And so that's one of the things that Accelerant really helped us on, was we could substitute modules in, we could update modules, change modules, update IO without having to do significant code rewrites. And we just had to add modules. Ed's going to spend just a little bit talking about some of the future trends, and then we'll probably start wrapping it up and then moving into some of the questions.
So we've talked a little bit about what Accelerant has, but as we've designed Accelerant, we've kind of designed it to move toward the future. So we have built-in flexibility to be able to expand and to customize just about every portion of Accelerant that we would want to customize. So we can replace certain portions if we need to, and we've taken into consideration and are actually in the process of working toward AI integration for some smarter testing here to help develop those test definitions and test scripts that we showed you. So we're currently working on some definition of AI for that. And then also we're working on the capabilities of implementing AI with the design of the user interface screen. So maybe placing some of your widgets and auto-generating a screen for you. based on what you tell it you want. Additionally, we've taken into account cybersecurity for secure operations. We're obviously looking toward the future, and quite a bit of other things. We also have the ability to potentially implement into different data management systems, like System Link Server, for example, that we'll be working on in the future.
All right. All right, so some of our key takeaways. We've designed Accelerant to be modular, flexible, and ready for whatever comes down the road. We do a lot of time trying to optimize it for the real-time control and being able to seamlessly integrate a lot of these different modules and stuff that we've created. And really from the beginning, that was a core design feature, is that it is going to be modular and flexible, that we'd be able to swap out virtually any part of it with a new, improved, or modified, or even simplified version to accommodate, a variety of pieces of test equipment that exist out there. So I think we're pretty close to starting to go through some questions.
Okay.
I know, Daniel,
so,
if you're going to read some of those.
I've been monitoring, and I've collected some questions, so I'm just going to throw those out here. So we'll start with, do I need to have an on-site server set up as a host for all my test sites?
You don't. Accelerant itself can be completely self-contained, where everything is on, one operator computer and a real-time controller. That's fairly common in the systems that we do. It doesn't have to be that way. Right now, we're doing a lot of work with System Link and being able to support, an entire lab and deploying versions. Because once you get to a certain point, it becomes tedious to have 20 different pieces of test equipment that are all different. It can do that in a lot of one-offs. That's exactly how it is implemented. It is a single machine with a controller, and then frequently that PC is networked, but it doesn't require any sort of networking or server.
Okay. Can Excel formulas be entered into the Excel definition with Accelerant reading the value rather than the formula? And I can answer that one because I use that all the time. Yeah, it will read the result of the formula, and that's one of what I feel like is a powerful feature of Accelerant. We've several times discussed whether we wanted to write a configuration tool, something similar to Veristan's system definition editor, if you've used that application, but you're limited to the interface that is provided for you. And since our definitions are done in Excel, you're able to leverage a lot of functionality that Excel provides for better, just something as simple as better copy and paste. But yes, formulas, color coding we often use to help us keep parts organized and doing different things and tracking stuff. So absolutely, you can take advantage of a lot of the functionality of Excel and then have those resultant values be read into Accelerant when we compile the project definition. Okay. Can the sequences be written in an offline editor, Python or other, and imported?
Yes. There's a variety of sequences. We can read in Python directly in the sequence editor itself. You can open a Python session, specify Python to load in and execute that. We currently don't execute Python on the real-time side. And the majority of our file structures are JSON text. So we've tried to keep as much as we can very generic. Like the command structures that actually go down to our controller are JSON text. There's very few items that we have that are sort of some sort of weird, proprietary or binary format. It's a lot of it's just JSON text. So if you wanted to script something, say in Python, and generate, accelerant commands and stuff, that's doable. We even have Python, partial Python API. We don't use it much right now, but you can issue commands via Python into Accelerant as well.
I would expand upon that a little bit. And one of the things Ed showed in the definition files is our some of the low-level real-time scripting. We have a real-time scripting language that is used in calculations, used in our state architecture and the sequences that are associated with that, as well as any of the real-time tests. And that is a custom scripting language that we've done, but I often use an offline editor, just something simple like Notepad++, rather than edit that in Excel, because I found on some of those larger scripts, Excel's not the right tool for writing a program, whereas Notepad++ lets me easily do that. And then I can actually reference that file from within my Excel script, and then during the compile, that gets sucked in automatically. As far as the high-level sequencer that Roy showed, currently, yes, it is a JSON file. It would be hard to edit manually, but you could do it, just because of a lot of the references to a lot of the dynamic classes that get loaded up that implement the different steps. However, we are close to having a simulated real-time component so that you can actually run that GUI and your actual configuration without a real-time controller. So like an engineer could install the Accelerant GUI and run, against a configuration, and then launch the test or the sequence editor and write their sequences offline, and then take those files to the test stand and then actually execute them there.
Yeah,
All
and
right.
actually, Ed touched on it. We are working on AI to actually generate those scripts. Just like, if you go into ChatGPT and you ask it to do something in Python, boom, it generates a Python script. We're moving towards having that. Made some progress, but so we imagine that in the future that will be something where you just simply ask it to generate a script for you, and oop, there it will be.
Okay, let's see. Had a few more questions come in while we're doing that. I'll ask one more question, and then I'll try to look at some of those new questions. What differentiates Accelerant from Veristand?
One of the biggest ones is it's completely open and flexible. We can, in Accelerant, so one of the key features of Veristand is it really does handle models very well. Lots of models and linking models together, and we can run models, but we're not quite, if you're going to do tons of modeling, probably want to look at Veristand. But we can also completely modify every part of our engine and HMI, all of it. It's all LabVIEW. It's all open, and you can swap whatever parts you want in and out for any particular machine. So in terms of, I think, the number of machines that would apply to Accelerant versus Veristand is, I think, much higher in terms of Accelerant versus Veristand. That's probably the biggest difference, is that you just have absolutely almost any machine we can get Accelerant to operate on it.
Okay. We've got a question from a user. I've seen the ACS front end on a few of the testers at our facility. I haven't had too much hands-on use with the control software. Since this is a very high-level overview of the software, I was just curious if there's provided literature or a place where one could go for using the ACS solutions.
Well, most of the literature online is, again, fairly high level as well. Probably the best thing is just see if we can just do a live demo for particular features and just dive into them, and using the system. So, but requesting an actual live demo is probably the best way to get more detailed info on it.
Yeah, we also have a contact us form on our website. And so you can use that and then we can get you the help you need. All right, let's see. Can the software only be used with NI processors and IO hardware?
Currently, only NI processors. So the Pixie, PXI, and C-Rio, Linux RT controllers. That's the current real-time target. But in terms of IO, we worked with a variety of different IO manufacturers.
I know we've done Beckhoff and Gantner, primarily
yeah,
through EtherCAT. That's the best way to bring in other IO type
yep.
devices is over EtherCAT.
If they're
any
compatible,
instrument,
if they're Linux RT compatible on the LabVIEW side, then the third-party devices will work. There's way more options on the IO side, but right now they require the Linux RT OS for the control software.
all right. Let's see. Is Accelerant targeted toward R&D or can it be used in manufacturing end-of-line environments? Can restrictions for operators be easily implemented?
Yeah, for both. The HMI does have a variety of user levels, so you can lock out changes to the HMI. The system technically doesn't even need an HMI. You can run headless. And so you can run it in production environments and in R&D environments.
All right, I think that's all the time we've got for questions today. So for next steps, I think we got a little bit here.
Yep. Yeah, some next steps. There is some, there'll be some links in chat, posted in chat. So there's some more information on the website. There is a white paper on Accelerant, provides kind of a high level indication. There's, I believe it's my email that is in chat. So if you want a demo or some more consultations, feel free to reach out to me. We'll try to set something up. This webinar is going to be sent to your inbox. Technically, we still have 4 more minutes though. So I don't know, Daniel, if you want to.
I was directed to kind of wrap it up. So let me see if there's one. We've got one more question here. That's good.
Sure.
Real quick. Is there any way to handle communication and data transfer to plant databases?
Yeah. Well, there's nothing that's like standard because communicating with a particular database, usually like, okay, there's what table, what blah, blah, blah. But that's actually a very common customization that we do. Like for instance, in our test sequencer, we'll just create a custom step that says, hey, write this to the company database or read something from the company database. And in those steps, you can create the edit screen and you can define all that. Like, oh, how am I going to connect to this database and how am I going to, read to it or write to it and read from it. Similar on the real-time side, you can do that as well. And we've done that also. It's like, well, how are we going to talk to this particular device? We just create either a custom service that does that. And once you've done that, based on our framework, you can send whatever values you want into that module or out of that module, right? So if you're getting values from a database, you can then disperse those throughout the system and say, oh, I've gotten the specific gravity of the fuel. Boom, I'm going to write that into this parameter and then route it wherever I want. And they can go into a calculation and so on. So So that's really how we'd handle that. We don't have like a standard, but we have all of the hooks to create the custom steps or services that need to do that. So,
yeah. So actually, we do have a service that's under development right now, which should be released shortly, that will be configurable for interfacing with a database via ODBC.
yep. So,
All right.
yeah, thanks everybody. Again, any more info or anything, feel free to email me. There's a bunch of white papers and website stuff. We tried to give you kind of a fire hose. Hey, here's a bunch of the features and everything, but there's just so much that's still available that just feel free to reach out. And that is it.
Thanks, everybody.
Yep.
Appreciate you taking the time to join us today.
Thanks.